Okay, guys, so today's lecture is Unit 1, Lecture 2, and this lecture focuses on acceleration, so make sure that you have the right notes up and you're ready to go. All right, so today we're going to focus on describing motion in terms of a changing velocity, and we will be doing the graphing of v versus t in class, so don't worry about that part. But we will be using these big three equations, we call them big three equations, to solve word problems. And so we're going to go through those together today. All right, so just remember as we start this lesson that when an object is traveling at a constant velocity, there's only one equation to describe motion, and we've only had one equation so far this whole semester, so we should hopefully remember it. But it's v equals displacement over time, or we write it as v equals d over t. Okay, so remember that is only used for constant velocity, okay, where acceleration would be 0. When an object has a changing velocity, it is said to be accelerating, okay? Now we normally think of acceleration as speeding up, but in this case, we're not going to use the word deceleration. So we're either going to have a positive acceleration or a negative acceleration, and we'll talk about what that means, okay, and how we assign those. It's not necessarily that speeding up is positive and slowing down is negative. That is not the case. It's a little bit more confusing than that, although we're going to do a lot of work with it, and you guys should hopefully be able to pick that up pretty quick, okay? So the definition of acceleration, we use little a, okay, and it is the change in velocity over some time period, okay? We can also write that as, we don't have to rewrite the a. We can also just write that as delta v over t. Okay, delta means change in, if you remember from math. Okay, delta v over t. And our units, if you think about this, right, velocity units were meters per second, over the units for time, which are seconds. So we get meters per second. Okay, and that's really important. We can change that if you were to go back to your math skills. Multiplying by the reciprocal of s over 1 would give you 1 over s, and so you could equal this to meters per second squared. But for our purposes right now, we're going to say meters per second because it will give us a better idea of what acceleration actually is, okay? A positive acceleration would be either speeding up to the right, okay, so increasing your speed to the right, which is the positive direction, or slowing down to the left. So if an object is moving to the left but slowing down, that means that the acceleration is to the right, right? So you can kind of think of it like if you had a car here and it were moving to the left, right? Then in order to make it slow down, you would have to push to the right, and so our acceleration would be to the right, okay, and that makes it positive. Negative, you're going to have speeding up to the left, so if you're going faster to the left, you'd be pushing that object further and further to the left, and that would give you a positive acceleration, or slowing down to the right, so exact opposite of this. If you had a car moving to the right, then in order to slow that car down, you would have to push to the left, and so you'd get a negative acceleration to the left. We sort of associate the push with the acceleration. Okay, so if you're pushing left, then your acceleration is going to go left. Okay. The big three equations. You do not have to memorize equations, but these are the big three equations. These are the ones you're going to use when objects are accelerating or changing velocity. Okay, and those equations are as follows. So we use v final, it's a little vf, okay, equals v initial, we use O for initial, it's actually v naught, okay, plus a times t. So that's final velocity equals initial velocity plus acceleration times time. That's the first one, okay. Second one is final velocity squared equals initial velocity squared plus 2 times a times displacement, okay. And the third is displacement equals v initial times t plus 1/2 acceleration times t squared. Just the t is squared. A is not squared, 1/2 is not squared. Just the t is squared. Okay? And these are the three equations that we're going to be used most when solving acceleration problems. Okay? Now, when we actually solve these problems, okay, there are some steps that we're going to follow. Let me just get you guys straightened out here. Some steps we're going to follow. Okay, the first step is you're going to read through the problem and make a variables list. So read through, look for any information that's given to you. Okay? Number 2, determine which variable the question is asking you for. Okay? So this first part you're looking at what's given. The second part you're looking at what are they asking me to find. And 3, you're going to choose the equation that you will use to solve the problem. This is the equation that contains the variables you have and the one that you want. Okay? You do not want to pick an equation that has a variable that you don't have and that you don't care to find. Okay, so you're looking for the equation that has the ones that you have and the ones that you want. And then you're going to plug in and solve. So we're going to follow those steps as we go through a few examples here. Chris's car can accelerate at a rate of 18 meters per second squared, okay, or 18 meters per second. So we're going to write down what's given. That's an acceleration. It can accelerate at a rate of, and you can use the units to figure out what variable is given. Okay, so I'm going to write down A equals 18 meters per second. Then it says if starting from rest tells you something. It tells you that your initial speed or your initial velocity is 0. You're at rest. So initial velocity is 0 meters per second. How fast will he be going after 3 seconds? 3 seconds is given to you. That's your time. Okay? And now now step 1 is done. We have what we're given. Number 2 asks you to figure out which variable we're looking for. How fast will you be going after 3 seconds? So hopefully you can see that that would be asking us for the final velocity. Okay. Now, before we plug into an equation, I want you guys to think about what acceleration really is here. Acceleration is the number of meters per second that we are increasing or decreasing per second. Okay. So our acceleration, 18 meters per second every second. If we start from 0 and we go for 1 second, let's say, if you're increasing 18 meters per second every second from 0 meters per second, then by after 1 second, you will be going 18 meters per second, right? So after 1 second, your final velocity would be 18 meters per second. If you went another second at the same rate, you would add another 18 meters per second. So you'd have 36 meters per second. Okay? After another second, so after 3 seconds, you would just add 18 to this, and you'd have 54 meters per second. So hopefully you can kind of see how that acceleration works. Every second, our velocity increases by 18 meters per second. Okay? Now, we just did that sort of by thinking about what acceleration means. If you wanted to actually plug it into an equation, right, you would choose the equation that has these 3 variables and this one. So the only variable we don't see in our list is displacement. So you want to pick the equation that does not have displacement in it. So that one does, that one does, that one does not. So we would choose equation 1, and we would say VF equals V naught plus AT. And then when you plug in, that's the one you're looking for. V naught is 0, A is 18, and T is 3. And so if you plug that into your calculator, you would see that VF equals 54 meters per second. Always put a box around your answers and always put units. You will get marked off on a test every time you forget to put units. So do not forget that. You do not have to carry your units through the equation because it gets really confusing. So I'd actually recommend not doing that. Okay? Now, this example is continuing off of this one. So how far did Chris drive in those 3 seconds? So we still have these same variables, although now we know the VF is 54. So we actually have all 4 of these variables, and we're looking for how far. So displacement is what we're looking for. So now you can pick either one of these equations. I like this one because the D is already in a position where it's going to give me the answer once I plug in. So I would use that equation. And for now, I don't want you skipping steps. So don't just skip to plugging in. I want you to actually write down the equation. Okay. And then plug in. V naught is 0. 0 times anything is 0, so I'm just going to leave that off. A is 18 and T is 3. Don't forget to square the T. Okay. And if you plug that in, you get D equals 81 meters. Okay. And make sure you have the proper unit. Okay. I'm going to pause really quick just to flip the page over. Okay, let's try another example and then I'll have you try one on your own here. Okay, so Becky is driving at 25 meters per second. Okay, hopefully we can see that that is the initial velocity given to us. I know because of the unit. Okay, and begins accelerating at 5 meters per second squared. So there's my acceleration. Okay, what is her speed after 10 seconds? My time is 10 seconds, and I'm trying to find her speed or velocity after that time. So final velocity is what we're looking for. Okay. Only a variable we don't have is displacement, and so if we look back at our equations on the previous page here, okay, the only one that doesn't have displacement is that first one, so that's the one that I'm going to use. Okay, and then I'm just going to go ahead and plug in. And if you go through and plug that into your calculator, you get 75 meters per second. Don't forget units, don't forget to box the answer. Okay. Now I want you to try this example here on your own. Okay, so write down the variables, get as far as you can, pause the video to do that, and then when you've done that and practiced it, come back and watch how we do it. Okay. All right, so here we go. So if Taylor's driving at 25 meters per second, that should be your initial velocity. Okay, slows down to 15 meters per second. That's the final velocity. Over 60 meters, I can tell that that is a displacement because of the unit. What was her acceleration? The only thing that I'm missing here, if I look at my variable list, the only thing that I'm missing from my list is time. So I'm going to go ahead and pick the second equation because I don't care to find the time and I don't have it. So that's how I choose. So I'm going to use this equation, VF squared equals V naught squared plus 2AD. Plug in, 15 squared equals 25 squared plus 2A times 60. And if you go through the math here, right, you got to square, you got to subtract this from both sides. Remember your algebra skills. Okay, if you're struggling with the algebra here, then you really need to practice this, or come see me and we can figure it out together. But this needs to be the easy part for you. Otherwise, the physics is going to be really, really difficult. So if you go ahead and solve for that, you come out with, let's see here, so 15 squared minus 25 squared divided by 2 and then divided by 60, you get negative 3.33 meters per second squared as your acceleration. Okay. And I'm going to go ahead and start a different part 2 video since we're approaching 15 minutes here. My video will pause, so I'm just going to go ahead and start a new video. Okay, so you're just going to have a quick pause, and I want you to go to part 2 to finish this lecture. You only have a couple minutes left.